In the last lecture of the high altitude, the ascender was going from the high pressure to the low atmospheric pressure. So now the person who is the diver, he goes deep into the sea, and deep into the sea, the atmosphere is having more atmospheric pressure. So what is the status of atmospheric pressure deep in the sea? As we go deep, the atmospheric pressure goes on increasing. So what is the atmospheric pressure at various depth of the sea? At sea level, the atmospheric pressure is 1 atmosphere. Then for the depth of 33 feet, the atmospheric pressure is increased by 1 atmosphere. So at the depth of 33 feet, atmospheric pressure becomes 2. Then at the depth of 66 feet, it becomes 3. Then at 100, it becomes 4. And accordingly, the atmospheric pressure goes on increasing. Why this pressure is increasing? This is mainly because of the weight of the water, and that is creating more pressure. So naturally, more deep we go, more is the weight of water and more is the atmospheric pressure. Now, when the diver descends down, he has to breathe. During this breathing or during the inhalation, there must be the expansion of the chest and there must be the expansion of the abdomen. But because of the compression from the outside, because of high atmospheric pressure, it becomes very difficult for the normal expansion of the chest and the abdomen. So to have the normal amount of air inside, the diver should breathe the air which is more positive, which is having more pressure. So how does he breathe the air with more pressure? This is because of the cylinder that he is carrying. In this cylinder is the part of breathing apparatus that the diver is carrying. In this small cylinder, large volume of air, it is then compressed and the air is present in very high pressure. So this high pressure of air, it enters into the body and overcomes the outside compressive pressure of the body and allows the expansion of the chest, allows the expansion of the abdomen and allows the air to enter in and the oxygen is then provided to the diver. So the air or the oxygen is being delivered to the diver in the high pressure. And this is by the cylinder which is containing air in the high pressure. Now, when we say the high pressure, that means high pressure of air, that means that all the components of air, they are present in more pressure. So there will be more partial pressure of O2 in the air present in the cylinder. There will be more partial pressure of nitrogen present in the air. So the diver, when he is taking the air from the breathing apparatus or the cylinder, actually he is taking the air which is having more partial pressure of oxygen and having more partial pressure of nitrogen. And these are the two gases which then produce a lot of problem into the diver's body. So what problems these two gases they produce into the diver's body? Because of high pressure of the oxygen into the inhaled air, there is development of what is known as oxygen toxicity. There is development of oxygen toxicity. And because of high partial pressure of nitrogen, there is the development of what? Nitrogen narcosis in the body. What? Nitrogen narcosis in the body. So, how oxygen toxicity is developed in the body? Now, before that, when the person is at the sea level, we consume our body, cells of our body, they consume 5 ml of O2 from every 100 ml of blood. This is already we have discussed into the oxygen transport. Out of this 5 ml of O2, majority of the O2 is utilized by the cell for its metabolism. Only small amount of O2 is converted into free radicals, which are known as oxygen free radicals. That is superoxide, hydrogen peroxide, and these free radicals that may cause damage to the cell. And to prevent damage to the cell itself contains the neutralizing system, and that is known as antioxidants. So whenever these free radicals or oxidizing radicals are formed, immediately they are neutralized by the antioxidant, and the cell is prevented from the damage. But what happens into the diver when it descends down? When the diver descends down, there is more entry of the oxygen with more partial pressure. More entry of the oxygen into the cell. Because of more oxygen, the demand of cell here also it is same. That is, for example, 5 ml from 100 ml of the blood. So more than 5 ml of oxygen is being delivered to the cell. Cell is utilizing the oxygen whatever its requirement is for the metabolism. Majority of the oxygen that is left, it is converted into free radicals, that is the superoxide H2O2, and these free radicals initially are being tried to neutralize by the antioxidant, but their number is so high that now they produce damage to the cell, and the cell is then damaged. The most susceptible cell for damage by the oxygen radical, it is the neurons of the central nervous system, and that is why the first sign and symptom of the oxygen toxicity is developed because of involvement of central nervous system. So what is the first sign? There may be the confusion, there may be the disorientation, there may be the muscle twitching, convulsions, coma, etc. that may occur because of the oxygen toxicity. So this is about the oxygen toxicity. It may develop acutely or it may develop over the long period, that is also known as the chronic oxygen toxicity. Second one, and very important one, is the nitrogen narcosis. Have you seen the person who is under the influence of alcohol? So nitrogen narcosis, it is very similar to that of alcohol intoxication. So let's see how does it happen. Now, say the person is breathing the air which is having high partial pressure of nitrogen, more nitrogen enters into the body. More nitrogen enters into the blood. Now see what happens. Because of the pressure from the outside, the body is squeezed, and because of the squeezing, the nitrogen, it comes out of the blood vessel. This nitrogen that is coming out of the blood vessel, it is then dissolved into the various tissues of the body, but it may be dissolved into the tissues where fats are present, for example adipose tissues, and for example the neurons of the central nervous system. So here it is mainly then deposited into the neurons of the central nervous system, adipose tissues, etc. Now this nitrogen at the sea level, it is inert, it is harmless, it doesn't do any function. But when it is dissolved into the nervous system, what does it do? This is the nerve fiber. Because of this nitrogen, the permeability of the neuron, it is then decreased. The ionic conduction across the membrane, it is then decreased. There is less excitability of the neuron. So actually the neuron is undergoing inhibition. So because of the inhibition, all the problems now get developed. What will happen is that initially, because of the nitrogen narcosis, what happens in the alcohol intoxication, the first thing that is developed is the person becomes jovial. careless, euphoria is developed, is not caring about what is happening, what is present around. So the first sign of nitrogen narcosis starts developing, and this is first the person becomes jovial, euphoria is developed, he becomes careless about the environment, and this happens at the depth of 100 to 120 feet. So where is at what depth the first sign and symptom of nitrogen narcosis is developing? At the depth of 100 to 120 feet. As the diver goes down, more nitrogen is dissolved into the myelin sheath, more effect on the nervous system, and further extra symptoms develop. They are, now the diver becomes confused. There is the disorientation. There is the diver doesn't know. Also, there is a weakness of the muscle. I repeat, as the diver descends down, the signs and symptoms, they are exaggerated, and they are exaggerated in the form of there is the weakness of muscle, tiredness, then there is the disorientation, and the confusion is also done. If the diver goes down again, say at the depth of 200 feet, now there is the development of what? Loss of memory. Already disorientation is there, memory is being disturbed. So diver doesn't know in which direction he is going, rightward going, leftward going, upward going, downward going. He doesn't know in which direction he is going. He keeps on moving deep into the deep sea. Ultimately, he lands up into unconsciousness, coma, and the death will occur. All these effects, they are developed because of what? Because of the effect of nitrogen, and hence it is known as nitrogen narcosis. So this is what is happening when the diver is diving down. One, oxygen toxicity may develop, and the second, nitrogen narcosis may develop. Sir, can all oxygen toxicity and nitrogen narcosis can be prevented? Yes, it can be prevented. How? Before diving, if the diver is doing the work deep in the sea for a long time, then all the nitrogen that is present in the diver's body, it is to be taken off. That is, there is the washing off of the nitrogen is to be done. How this is done? Allow the diver to inhale the air which is having oxygen, and in place of nitrogen put the helium. So there is the breathing of air containing oxygen and the helium. So helium is going in, and during expiration nitrogen is coming out. So this is taken for some time till no nitrogen is coming out from the body, and that time the nitrogen is completely washed out from the body. Now when the diver is getting down in the cylinder, instead of putting the nitrogen, put the helium, and that will prevent the development of nitrogen narcosis. Also, decrease the concentration of oxygen into the cylinder. That will prevent the development of oxygen toxicity. So, in short, what is the composition of air in the cylinder? Less oxygen and more helium. Now the question may be put, sir, why helium? The reason is that the density of helium is less than that of nitrogen. That means it is lighter than the nitrogen. Second, it can diffuse across the respiratory membrane very easily, and it can distribute throughout the body very easily. And last one, the toxicity. Helium is not free from the toxicity, but toxicity of helium is only 20% as that of nitrogen. That is why we use the helium in the cylinder when the diver is going deep to work for the long time. So this is about when the diver is deep. Thank you.